Hi, I'm Course 1 Professor Primary 6 from YUMIN Primary School. For this time, we are still continuing with ordinary differential equations. In ordinary differential equations, we'll give many different types of examples. And in each of these examples, although we might use the same method, but one little change can cause a big difference. Okay, so let's take a look at what type of example we have here. Well, I write this down again. This example is y prime prime minus 4y prime plus 4y, and this is equal to e to the power of x. So let's check what type of ordinary differential equation is this. This ordinary differential equation, first, let's look at its coefficients. 1, negative 4, 4. So that means this is constant coefficient. So this is constant coefficient, second derivative. Is this linear? Yes, it is linear. You just look at this. Y prime, and y prime prime. So yes, it is linear, but it is non-homogeneous because this is not equals to 0. It is e to the power of x. Okay, so let me just say this again. This is a second derivative, constant coefficient, linear, non-homogeneous ordinary differential equation. So the method we use for this, since we are finding the general solution for the non-homogeneous differential equation, so we can take it as the general solution for homogeneous differential equation and the particular solution for non-homogeneous differential equation. Okay, so let's write that down. So let me say this YG, that is YH plus YP. Let's first think about this YH, the homogeneous. So we just take this e to the power of x just as a 0. So take this as a 0. Then we can let y be e to the power of lambda x. Okay, can be like this. Then sub this inside. So e to the power of lambda x will simplify from this whole equation. This is what you get. Since this is what you get, so let's see. Let's factorize this. Oh, then find it is lambda minus 2. That means this lambda, although it has, well, 2 roots, but they're still the same. But we have to write it down. So that means this lambda 1 is equal to lambda 2. That is 2. Now, how do we write this? YH. The first part, C1 e to the power of 2x. Well, we have always used this form. But how about the next? What if the next part, I still write it like this. But if we just write it like this, these two combine. So even if you write it like this is useless part. But what if I times something? Of course, we need to times something. What if I times x? So let's check the product rule. So the product rule is, okay, you differentiate uv. First part, it can be differentiate this u. It can first differentiate the v. So this is a product rule right now here. Because right now here we only have 2 parts. So here we only need 2. So let's check. If you differentiate this x, that means the left is e to the power of 2x. But still this part, well, is just 0. This part will 2. But this x part might cancel out with others. So, okay. But if you have a square, then until this part, then you still have an x there. That means it can't cancel out. If it can't cancel out in this part, it doesn't have it. So it cannot go until square. All those, you don't need to think of them already. So this part is for our homogeneous. Okay, next. This particular solution, yp. So we'll let. Now we still have to let something. We will need to let yp be something. Let's think of this. This will need. Okay, this part is exponential. So if we need exponential, that means algebra, well, we don't think of that here. So we'll just think of this. Okay. So we'll just write it as a e to the power of x. Now this a is just that coefficient that we don't know. So then we just have to solve this. Then first derivative, same thing. Second derivative, actually still the same thing. So all these three are actually just the same. So at this part, that means, okay, let me just write everything out. But wait a second, these two parts just cancel out. That means a is just 1. And then yp is e to the power of x. So yg, okay, here is so yg, it's just these two parts add together. This part, you can factorize that e to the power of 2x. Okay, like this. This is our yg. But do we know is it correct or is it wrong? We'll need to verify this. Okay, let's verify. So this yg then first derivative. First derivative, you have to be very careful of this. Here, we need to have product rule. So what if we first differentiate this? That means it's C2. Wait, here's an X. This part behind is still e to the power of x. But wait, if you differentiate this part, then you'll have this extra 2. Okay, so that means it's like this. This is the first derivative. Second derivative. Differentiate this part. 2 of this. But wait. Behind here, differentiate, you get this. That means you have another 2 of the C2e to the power of 2x. That means you have 4 of these. Then this part behind, another 2 comes down. And this is what you get. Next, we'll sum all these back here. First part. Second part, you have to be careful. This is minus this part. And 4 of this. Then you have to add, okay, still 4 of these. Then we have to check what is this equal to. So let's find those that we can combine or just cancel out. Firstly, here, these 2 parts. Okay, these parts we're pretty sure that we can cancel out. Next. Wait. I mean, this part is actually 4. Okay. Yeah. Then is this part with this part and here. Okay, that 3 parts cancel out. Next, this one, these 2, they also cancel out. So what's left is e to the power of x. And we get our original part. That means this is right, because when we sub this back inside, it gets what we want. Okay, so these steps are actually pretty simple. First part, characteristic equation. Second part, comparison of coefficients. Then after that, those 2 solutions add up, get the general solution for the non-homogeneous differential equation. Then we sub it back inside here, verify. But you have to be really careful about these calculations. Okay, so this example is actually pretty simple, but you need to use a lot of these examples. Like, it goes harder and harder, so that, like, when you think, it'll be very easy, because if you just straight away go for a hard question, you might not even know what's the method and how can you deal with it. Okay, so for this lesson, I'll end it here. So if you like our videos, don't forget to subscribe to our channel. We'll see you in the next lesson. Thank you for your watching.